So let's look at this question here, which is taken from the year 2004, paper 1, question 5. Now the numbers x and y satisfy this equation here. If a real value x is substituted, so this value here is substituted into the equation and becomes quadratic equation in y, given that the two distinct real values of y may be found in this equation, show that 5x squared plus 8x plus 3. Okay, so basically if x is substituted with a value, what we could do is just assume that actually x is like a constant because it's being substituted a value. So it's wise to just make y square the y square the quadratic expression here. So I'm going to just rearrange this to y square plus 16xy plus 14y. So what I'm going to do is I just take the coefficient of y, group them together. Then the constants will be 4x squared plus 16x plus 13. So this will be plus 4x squared plus 16x plus 13 equals 0. Okay, so y squared, then 16xy, 14y, and so okay. So now I'm gonna make this here 16x plus 14y plus 4x squared plus 16x plus 13. Now once you rearrange this, in this case here, since there's real value, so since there's two distinct real values of y, in other words, the discriminant would be more than 0, and the other words is 16x plus 14 squared minus 4 AC would also be more than 0. So this case here is pretty okay. Once we've done it, we're just gonna expand it, right? 16. So I'm just gonna quickly expand 16 square very quickly. 2, 5, 6 x squared plus 16 times 14. So I'm 16 times 14 times 2. 448x plus 14 square. That will be plus 196 minus 16x squared minus 4 times 16 will just be 64x minus 13 times 4 will be 52. Okay, the good thing about this is actually showing question, so I would know whether I have careless mistake after this. So I'm not too concerned about it now. 196 minus 52. Well, of course, we try and minimize the error here. Within 0. So we are told to show that this is a quotient of 5. So we try and take 640 divided by 5. You need to divide by 48 then. So divide by 48. 5x squared plus 384 divided by 48. 8x and 144 divided by 48. Would that be 3? Tada! That's how you do this question here proficiently. Shown. Okay? Shown. Now then, after which, hence find the set of possible values. So this case is okay. We just need to set of possible values would be 5, 8, 3, and this will be 5x plus 3 and x plus 1 bigger than 0. So this case here it will be bigger than -1. Then -1 and -3 over 5. That will be a positive, negative, positive. We need here, here, here to here. So in other words, x will be between -1 or x more than -3 over 5. Okay. Now, what can you deduce about the curve equation? So, what we can say is there's no real value. Okay. So this part, if there are real values here, from this equation we can say that the curve has real values for the range. Just quickly type -1 or x bigger than -3 over 5, but it has no real values, no y values. Actually, no real values or no y values. Has y values for the range and has no y values for the range. This is what we can deduce. -1 x to -3/5. Okay, so just quickly deduce this. So you could assume that actually once you plot this curve out, you can actually see that there's no real values between -1 to there's no real values between this value here, but or you have two real values. Or you could actually, okay, maybe we write this, okay? So you could just write that, you can just write that the curve cuts the, okay, this is what you can write also. The curve cuts the vertical line from x less than or -3/5 twice, okay, and it has no real y values between -1 x. Okay, I think there are many ways to interpret this. So yeah, so any question at all, please let us know. Keep practicing, and I will see you in the next question.